Assalamu alaikum wa rahmatullah. Hello everybody. I hope everybody is doing well. This is my latest project and it's mini project, but I want to share it with you because I found a lot of interesting points. First of all, this project is talking about finding the optimum thickness for inductor winding. And so what I supposed to do is to use my equation called Dole's equation. This equation predicts the copper losses in the inductor winding. But the problem here, this function is full of hyperbolic and trigonometric functions. So to find the optimum point, I need to differentiate this equation and make it equal to 0. But as I said before, this is very complex. So what I'll do is to move to MATLAB and try to find a built-in function, numerical methods, etc. so I can find this optimum point. So I'll share with you my code and share it, plus the problems I faced, how I solved it, and tricks about the code. And if you have any suggestion to improve my code, this would be amazing. I encourage you to do this, and I hope this video would be helpful. Okay, let's go to MATLAB right now. Here we are in MATLAB. This is my equation. This is the first thing I thought about to write my equation, but there is a little trick here, which is any programmer used to write or define his variable in numeric data type like integer, float, double, etc. But here we need to use a symbolic variable, not a numeric variable, because the numeric variable is the variable in which we store a value, a numeric value. We don't need this here. We need to use the variable as just a symbol without storing any value in it. Okay, so we will use this keyword. Second thing is after writing this equation, we need to use this function to transform our expression, our symbolic expression, okay, to a MATLAB function so MATLAB can deal with it. After this, we will use a function called fmin boundary. Okay, this function I found it by tapping here. Okay, I know I need a mathematical function, so I clicked here, mathematics optimization. I found fmin boundary. I clicked. After clicking, I saw the documentation, more help, open help browser. So I found this documentation. I use AI tools also to help me understand very well. Then I use this function. It takes your function and a minimum boundary and a maximum boundary. Okay, limits, lower limit and higher limit. So I thought in the beginning, and everybody I think he will think the same way. The wider the range, the more luck to find your point, because you can put narrow range, and this range does not include your minimum point. So I put at first 0.01 and 10. Okay, this is very important point here. Okay, so focus very well. When I use these limits and I start and I clicked run, the value was 6.7467, and this is a very, very, very bad value, or the wrong value 100%. And I was like, why this is happening? I searched a lot, okay, and AI tools told me this is because the non-linearities of the function. I tried a lot different ways, use another function, but I found a great solution, which is to plot your function in terms versus your variable, okay, and detect the lowest point by your eyes. So when you detect, you will find it between like here 0.3874 and here 1.15. So after knowing this by your eyes, you put it in your limits. So I decided to put 0.01 and 3. So after clicking run again, 0.7105, this is the optimum point, that's for sure. I tried another function actually and I was searching about function to find the minimum point without using limits, just initial condition, okay, initial point for iteration. So here it was 1. When I click run, it gave me the right answer, okay? But unfortunately, when I change this value to 2, for example, it gives me a wrong answer. It's like it crashes or what, I don't know what the problem. The last thing I want to share with you or to tell you is plotting your function is a very good way to know your limits, okay? And it minimizes your iteration number. So I think this is a very practical way to solve this problem if you have one in the future, and that's it. If you have a way to put wide range of boundaries, or regardless of your boundaries, you will find the right solution. Please share it with us so we can use it. And thank you very much for watching. I hope this small tutorial helped you, and thank you very much.